first thing that you learn in math? What is it? Counting 1, 2, 3, 4, 5, 6 and so on, right? This is actually a number pattern and it also has a name. It's called natural numbers. We normally represent it by n, right? So on a line 1, 2, 3, 4, 5, these are nothing but natural numbers. We can now count everything. Let me take a basket. There's 1 apple here, 3 oranges, 4 fruits in total, right? Now, what if we want to represent what is left in the basket, right? We could represent the fruits using natural numbers. How do we represent what is left in the basket? There is nothing, right? There's nothing. How do we show nothing with natural numbers? You can't, right? Which is why we now bring in a 0, right? If we include 0 to the set of natural numbers that we already had, we now get whole numbers. These 0 to infinity are nothing but whole numbers represented by W, right? Again, there are infinite such numbers. Let's now see what numbers we get by adding two whole numbers, right? Say we add 2 and 5. We get 7, which is also a whole number. Try 3 plus 8. That gives you 11, which is again a whole number, right? So adding whole numbers is still giving us whole numbers, right? So we can still work with these. Now, what happens if we subtract these two numbers instead, right? We do 3 minus 8. What does that give you? Minus 5. Now, minus 5 is not a part of our set of whole numbers, right? Is not a part of our set. So what do? To be able to represent minus 5, we add another set of numbers to the left of 0. These are nothing but negatives of the natural numbers, right? So we add negatives of the natural numbers to the other side. This entire set of numbers that we now have is called as integers, right? Represented by I, again an infinite set, right? So, okay, do we now have all the numbers possible? Seems like a lot, right? But not really. Let's zoom into a section of the number line to see. Let's say we zoom into 0 to 1. Can we have more numbers here? This is 1 unit, right? This is 1 unit. Can we divide it into smaller units is the question. If we can, then we would have numbers in between, right? So instead of a section, let's imagine it to be something like a pizza, right? Let's imagine this to be a pizza. Let's move the line down. Let's have a pizza instead of the number, right? Now, can we divide this? Essentially, we want to divide this unit, right? This is 1 unit. We can divide it into 2 halves like this. So between 0 and 1, there is 1 point, which is the half, correct? Now, if we take this half, you can further divide it into 2 quarters. What does that tell you? Between this half, there is a point which is the quarter, right? Similarly, this quarter, you can further have a point 1/8. This 1/8, you can have a point 1/16 and so on, right? We can keep going. We can keep slicing it into smaller and smaller pieces and we can keep dividing our number line, right? So what does that tell us? That integers are not enough to represent all possible numbers there are. In fact, between every two integers, there are another infinite set of numbers, right? We were able to divide it infinitely, right? We can keep going on and on, right? So between any two integers, there are again an infinite set of numbers. Now, these numbers that we just got are called as rational numbers, right? Rational numbers, the definition for these is nothing but any number that can be represented as P by Q, right? P by Q, where P and Q are integers, Q is not 0 and P and Q don't have any common factors, right? So that is essentially what a rational number is. And actually, even all the integers are rational numbers. Why? Because Q can be 1, right? If you put Q equal to 1, they all become integers. So integers are rational numbers.
If you like this video and want to watch many more amazing videos like these, like and subscribe to our channel now.